Alright, here is a short video on how to do problems 1 and 2 on the extended review. My recommendation is, like always, try it on your own, and then when I give you a piece of information in the video, pause it, see if you can go on from every piece of information that I get. Now I'm going to work continuously just to keep a decent time, but once I put some information up there, see if you can pause and finish the problem, and that goes for 1 and 2 here. So the first problem is saying that PT is tangent to the circle N at the point T. So point T is the point of tangency, where it's the one intersection point when it comes to tangent, and that the area of the circle N is 25 pi centimeters squared. Another piece of information, MP equals 4 centimeters, and we're looking for the length of PT. So one thing that we know right away, I want to make sure that I'm on my marker, that M to P, that distance, is 4 units long. That's a good piece of information. I know just by working with circles, it's always helpful to have a radius. And that also, if I can find the radius, that's the distance from N to M, and I can have that total distance NP, which will be helpful to me later on. So the first thing I'm going to do is use my area to find the radius. And I'm going to do that by knowing my area equation, pi times the radius squared. And I know that that radius equation I can set equal to the area in this problem, which is 25 pi. Now if I solve this equation here, what I've set up, I can figure out what the radius is, and again, a good piece of information. I'm going to divide both sides by pi, in which case these cancel, and so do these. Pi over pi would just be 1. That leaves me with r squared equals 25. Then to finally solve for my radius, I need to square root both sides, which leaves me with r of 5. And so the radius, any radius I draw in this circle, is going to have a distance of 5, and I'm just going to put that piece of information, actually I'm going to erase so that I can continue to work, but I'm going to add that piece of information once it's erased. So I know my radius is 5, I still know that that distance is 4, and then the next thing I'm going to do, and I'm going to try to draw it as straight as I can, I'm going to connect N to T with a radius. Now that's going to do a couple things for me. One, I can label that distance as 5 because I know my radius is 5. And I also know that when I connect a radius to a tangent line at its point of tangency, it forms a 90-degree angle. That's a big one, okay? So now I have the distance 5, I have a 90-degree angle, I have a right triangle, and I know that N to M is 5, and then M to P is 4, so the total distance then would have to be 9. Okay, once again, N to M is 5, because that's a radius. M to P is 4, so the total distance must be 9. Now I have a right triangle. I'm missing PT, and I'm able to use Pythagorean theorem to solve, and that's going to give me 9 squared, because that's the hypotenuse. Hypotenuse is always across from your 90, equals A squared, which we'll call 5 squared, plus B squared is my missing side, and we'll go on to solve. This is 81 equals 25. Plus b squared, subtract over, this is 56 equals b squared, and then square root both sides. I would accept 2 answers, b equals the square root of 56, or if you wrote it as 7.48, I believe, as the answer, and I'll get past my watermark so you can see that. We're going to jump right into the second problem here, just to make sure you know that 7.48 or the square root of 56 is my answer, because that would be the solution to the missing side of the right triangle. On to problem number 2. I did ask in class that you change these 2 measurements, otherwise the problem would not work out as nicely. I did give you then that FG, so F to G, that arc measure is 82, and E to H, that arc measure is 106. I told you to change that in class. Okay. Now this is a big idea, and one that we've talked about a lot during the chapter and a lot during our reviews is if my arc measure is 82, let's start with that one. If the arc measure is 82, then what is the inscribed angle? And again, I know that that's the inscribed angle because it goes out to G, and that same angle goes out to F, creating the 82. And we really need to be fluent in the fact that if that's 82, then the inscribed angle is half of that, making it 41. We're going to use that same concept here as we saw for F. I'm going to use an arrow so I don't cram too much room there. And again, that angle F, it goes out to E, it goes out to H, it creates the arc measure 106. Well, again, same relationship. If the arc measure is 106, we cut it in half to find F, and that would give me 53. before I even start answering my question of calculating angle E, which I actually have, and my angle GPF, let's find the missing angle of the triangle by doing 180 minus 41 and a minus another 53 to see what's left over. And I believe what is left over here is 86. And you can use your calculator to check that. So that missing angle right there is 86. Now I solved all those angles just using inscribed angles, and I just kind of kept going because I was in the groove. All right, but let's go back to the question, which was to calculate the measure of angle E. I did that right here. By using the inscribed angle relationship, I used the 82, cut it in half to find the 41, and that was angle E. So angle E is done. It's 41. The next thing to look for, and I'll change colors to blue, is this angle right here, GPF. G to P to F. It's the one in blue. Now, what you might notice, and the best way to probably see it, is that this angle in red, which you would maybe call EPF, is that 86 number. That's what I found right here. So that is actually 86. And that angle in red and this angle here in blue, when you put them together, it creates the straight line. And we know from a long time ago in geometry that a straight line has 180 degrees. So what I'm going to do to find the blue angle is I'm going to take the 180 degrees from the straight line. I'm going to subtract away the 86, and I'm going to see what's left over for the blue angle to take hold of. And when I do 180 minus 86, it leaves me with 94, and that is that angle that I'm looking for. So the measure of angle, let's make sure I label it right, GPF is equal to 94. All right. If you have any other questions on the review, I do have an answer key posted. I may not be able to make additional videos here tonight, but use the answer key, and if you have further questions, I could try to answer them through email.